Okay, our next section is titled Trigonometric Functions of Any Angle. Now, we've been traveling and staying right in our comfort zone, which is angles that are from the special triangles, 30, 60, 90, 45, 45, 90, and now it's time to venture outside of that comfort zone, even on our rotation. So we're going to see that, and we're actually going to do a special activity to help you find out what's going on. So this is the setup for that special activity. We'll do this in class, so you'll probably be watching this after that, or if you are watching it before, just know that we will be doing this in class, a little discovery. Okay, knowing that, we should then find out also that from our book that if we know the coordinates of a point on a circle are nothing more than the sine of theta, cosine of theta, or sorry, I said that backwards. Cosine, alphabetical order, x, y. And so we're looking at cosine, sine. Ordered pair, alphabetical order stays true even when we're moving on the unit circle. So in this case, if I don't have a unit circle and I have something that's bigger or smaller than a unit circle, whatever that radius is, obviously on a unit circle it has to be a 1, but if something other than 1, then we would use that, and that would be our measurement we would use, and each of our sine cosine values or cosine sine values would get multiplied by that r value, is the only really change in our work. Okay, so keep that in mind. We'll show you an example with that towards the end. This slide also, we've been working with them for several days now. These are the special right triangles from geometry we expected you to remember, the 45, 45, 90, and the 30, 60, 90. And each of their sine, cosine, tangent values are listed. You don't have to have them all memorized. We talked about if you do the sines, sine of 30, sine of 45, sine of 60, you can get all the others by the complement theorem, the definition of tangent. But after a while, they just become second nature. They will be ingrained. Okay, and that's what we're hoping. The Pythagorean identity will be used more probably in chapter 14, but they do want you to be aware of it in this chapter. It's something we're expecting you to come from geometry with. Okay, so knowing that, our goal today is, and it was an activity I think we did when we did the unit circle, is if we are in our comfort zone with 30, 45, 60 degree angles, which came from our special right triangles, then we want to be able to float around and go to any of these other positions that also are made up of 30, 60, and 45s in the other quadrants. Once we make a full rotation, we know we're back to the beginning and we should be good. But we need to acquaint yourself with where you are in those different quadrants. So you can see, check yours, that we've got 120, 135, and 150 if we're traveling in the second quadrant. We've got 210, 225, 240 if we're traveling to the special angles in the third quadrant. And then lastly, 300, 315, and 330 if we're traveling in the fourth quadrant. Yes, there's other angles we could go to, but not when we say find exact values. Okay, if you go to any other angles in those quadrants, you will be going to your calculator or some technology, maybe a chart and table. Okay, do not forget about the 90s, 180s, 270s, or multiples of 90, because they're even easier than the 30, 60s, and 45s. All right, so we are really good, or supposed to be really good with where we're at in the first quadrant. And just remember, when we do travel, when we do travel to that first quadrant, we're saying the position where the values hit. Okay, and that's not working too well, so let's just draw it. And where it intersects the axis, So if we wanted the intersection, we were talking about that spot there, and that spot there, and that spot's there. So not out at the end of the ray, right on the unit circle. Okay, so with that, you should be able to do sine of 30, cosine of 30, cosecant, any of those, tangent of 30, 60, and 45. So let's go travel right to that second quadrant where we're really not familiar yet. So again, look at each of these. You should be able to go around and say, oh yeah, if I'm 30, 45, or 60 degrees off, if I'm at 90 and I'm 30 degrees off of that, I'd be at 120. If I'm 45, I'd be at 135. If I'm 60 degrees off of 90, I'd be at 150. So we're looking at 3 different combinations, and those are the 3 you should be able to know and be able to do well. So if we now ask what is, and let's just use red as this example, if we ask where would we be at if we were at the sine of 120 degrees. So it would be that position on the unit circle. And so as we know, we found out the sign in the second quadrant is positive, so we know we have a positive answer. However, what you have to remember is we're good at everything in the first. So ask yourself, how can that ray get back to the first? And from what we did in geometry, what we did in geometry was rotate, translate, reflect. We did all kinds of things. The easiest way to get this back would be to reflect it back, and when we reflected it back, it'd be sitting approximately right there, which we should know is the 60. So we're really looking at what is the 60 in the first quadrant. So wait a minute, we know that. The sine of 60 is square root of 3 over 2. So if we can put that back and say, oh, that's the same as 120, and notice that parallel effect here, we would have the square root of 3 over 2. The only thing which we already analyzed was what is the sign, positive or negative there, and the sign is still positive. The y value is positive in both the first and the second. So we're good. The sine of 120 is square root of 3 over 2. We could ask you to do sine, cosine, tangent, or for that matter, any of the trig ratios once you're in the second quadrant. It's a reflection back to the first, and you're only going to reflect with those combinations when we ask for exact values. So let's travel to the third quadrant. All right, we'll do them in order, no special reason, but they came in order there. So if I ask for what are the values in that third quadrant, again, you can do, well, I know 30 off of 180 is 210. I know 45 off of 180 is 225. I know 60 off of 180 is 240. So if we've done all that, we should now be able to just handle how do we get these rays back to the first quadrant. And in this case, it doesn't matter which one you use. We're using the 225 in this case. It would be like vertical angles. So watch, I did the one that's like cut in half, so that was easy. So that's the same as a 45. So if we asked question on this one, let's do the cosine. The cosine of 225 equals what? You'd be thinking, well, wait a minute. That's the same as a 45 back in the first. And then you just have to apply what sign value, positive or negative, should your new angle really be. And so here we go. We know the cosine of 45 is square root of 2 over 2. But the cosine is positive in the first quadrant, but we're actually here in the third quadrant, which means we have to take into account cosine x value. That's negative, so we need a final answer of negative square root of 2 over 2. We'd do that on any of them. Now let me just show you what the reflection or the vertical angle deal is here. With the red, it would have been over here, so that red wedge would have been the same as the 30. Think about reference angle, quickest way to get back to your axes. So the red would be the 30, and the orange would be the 60. If we did vertical angles, it would end up here. Didn't make my line very straight there, did I? But that would be our 60. Okay? So one last quadrant to travel to. And again, ask yourself, what would these be if we traveled to the third quadrant? 270 and 30 is 300. 270 and 45 is 315. 270 add 60 is 330. So you can see your angles. Now again, let's go, we haven't done the orange, so we're doing orange this time. Ask yourself, how could you get these rays, any one of them, to that first quadrant? And again, you'd be thinking it should be a reflection over that x-axis, and if we reflect it over the x-axis, we're looking at an orange to be approximately there. So if we said, and let's do this one this time, let's say, but I do have orange outpicked, so let's do the tangent of 300. Okay, so the tangent of 300, in your brain you're saying, well, wait a minute, that's nothing more than a 60-degree in the first quadrant. So if I know what the tangent of 60 is, I can do the rest. The only thing you have to take into account again is tangent is not one of them. Some of you have memorized, so go through and say, well, wait a minute. What is, in our definition, it's sine over cosine, tangent. So the sine of 60 is square root of 3 over 2. And the cosine of 60 is the same as sine of 30. Sine of 30 is 1/2. That's a division, but we never divide with fractions. We always multiply by the reciprocal. So this is that square root of 3. So the tangent of 300 is the square root of 3. Not so fast. Be careful. Remember, you always have to go back to where you're at. And in that third quadrant, the cosine value is positive, but that sine value is negative. So this would have been a negative divided by positive. Negative divided by positive is going to give us that ultimate negative answer. So our final answer would have, we would have a negative root 3 for the tangent of 300. These are all exact values. All right, one other function is what we've just done basically now is if we keep twirling in these rotations, you know some of them are going to start repeating. Well, that periodic or repeating effect is tended to be called its period. So reading here, a function is periodic if there is a number p such that f of x plus p really equals the original f of x for every x in the domain of f. The smallest positive number p that satisfies the above equation is called the period of the function. So what is the smallest amount of rotation I can go through in this case, since we're on a unit circle, and still give me back to where I started? And as you can see, sine, cosine definitely will repeat after we have one full revolution. Okay, so 360 degrees. Last but not least, I need this chart filled in by you guys to just get a better idea of where you're at and to look for some patterns. And then when we look for some patterns, we're going to see some things that will be more for our discussions than anything else. All right, so have a chart similar to this filled in. Notice it's just cosine, sine, x, y for every degree, 30, 45, 60 in the first quadrant. And then you get your y-axis, which is 90, and then your 30, your 45, your 60 in your second quadrant. And then you're at your x-axis, and then so on, right on down. Y-axis, 30, 45, 60, and you're back at the x-axis. So fill those out from memory, not from a table, not from your calculator. We don't want decimals. We want exact values. Instead of drawing a whole circle as a hint, sometimes you can just draw a regular circle, divide it up with your xy axis, and then just put your little tick marks of your 3 entries. So you can use those for counting purposes. Whoops. For counting purposes. I missed that one up there. Try to get them approximate, and so then you can just go around and count on the tick marks. And don't forget really that your x-axis and your y-axis are tick marks as well. Okay? So do that for me. And then lastly, I promised a couple examples. We already did some like this. We can come back tomorrow and see if you have any questions. But how would you get the exact value? You would spin to that location. You would find out if the sign, positive or negative, for that quadrant is involved. And then you would write the 30, 60, or 45 exact value of what you need. So I can use those tomorrow as a check. So that means these also would be good checks. So if you want to just try them and see what you have, that'd be good for you. You can spin positively and negatively all around the unit circle. And then here is that one I alluded to earlier, and that is if I give you a circle that has a radius other than 1 unit circle, so this happens to have a radius of 7, then how do we find that point? And this one wants the exact value, so it wants both x and y. So when you're thinking, well, x is nothing more than the cosine, and it was 135, and y is nothing more than the sine of 135. So start thinking right away. You can look at that and say, well, the x value is negative, so we know whatever we're going to have is negative, and the sine value is positive, so we know we're going to have a negative positive ordered pair. And last but not least is, what does that represent back in the first quadrant. And most of you know that that 135 is a 45 wedge smack in the middle. So these would be 45. So the cosine of 45 is square root of 2 over 2. But don't forget to multiply it by that factor of 7 for the radius. And the sine of 135 is also square root of 2 over 2. But again, don't forget to multiply it by that factor of your radius. So our final answer, exact values would give us negative 7 square roots of 2 all over the whole number 2, and positive 7 square roots of 2 all over 2. That's all we have for today. Keep working on these, getting faster and faster and visualizing them rather than have to draw it. That will help you in the long run. Okay? So